This is Carbon Sequestration with Caleb, Sarah, Kara, Chris, and Emily.
What's the problem? The problem is increased carbon dioxide emissions from factories and transportation and other sources. Heat-absorbing gases cause global warming. This also causes depleting ozone layers and also rising sea level.
What is carbon sequestration? The technical definition is a natural or artificial process by which carbon dioxide is removed from the atmosphere and held in liquid or solid forms. Essentially, this means finding long-term storage or use for carbon dioxide emissions.
Can we fix it? Yes. Multiple solutions have been discovered in the form of biological, physical, chemical processes, and more specifically, research has been done involving the conversion of carbon dioxide into baking soda and ethanol.
The biological processes involve restoring the natural carbon cycle. Peat protection, forestry, and wet land restoration basically involve increasing the amount of plants to act as greenhouse gas exchange. There's also agricultural solutions that will serve as natural carbon sinks that will help preserve and rebuild the negative effects of the carbon emissions as well.
There are physical processes that can be used to help maintain the carbon cycle. We can use biomass replacements for fuels, and we can even store carbon dioxide underneath the surface of the ocean as long as it is deep enough to where it's more dense than the surrounding liquids. And we can also use geological sequestration, which means that you are basically injecting the CO2 deep into rock formations.
There's also 3 chemical processes that can help with this. Mineral carbonation would be the first, and it involves the reaction of CO2 with a compound that forms stable and typically insoluble carbonates at normal conditions. This occurs naturally and would eventually lower GHG emissions through natural weathering of crystal rocks. Also, in industry use, CO2 can be used in refrigeration and cooling and in fire extinguishers. Also, chemical scrubbers and devices that absorb different gases. Carbon dioxide scrubbers absorb CO2. Basically, air is funneled through the device and a sorbent material can chemically bind with the CO2, extracting it from air.
A more practical use is turning carbon dioxide into baking soda. Microcapsules permeable to carbon dioxide that contain dissolved sodium carbonate and water are used to capture the carbon dioxide and convert it into the usable form of sodium bicarbonate, also known as baking soda. Inside of the microcapsules, the reaction occurs that forms baking soda from carbon dioxide, water, and sodium bicarbonate. Baking soda is a much more useful form of carbon sequestration. There are multiple uses for it, including paper, glass, and detergent production.
Another useful solution to carbon dioxide emissions are converting carbon dioxide into ethanol. Ethanol is produced by using copper, carbon, nitrogen-based catalyst, dissolved sodium carbonate, water, and an applied charge. Charge is necessary for this reaction to occur. And basically, carbon dioxide can be stored and converted into ethanol using a reverse combustion process. Ethanol can be used as a good fuel and a good way to store carbon dioxide that is no longer in the atmosphere.
We use various sources to show how these different processes can allow engineers to solve carbon sequestration.